What if I told you that China just made the Jetsons a reality? That the once impossible dream of flying cars zipping across city skies is no longer science fiction, but unfolding right now, above real streets, with real passengers, under real government approval. Just days ago, sleek, electric flying vehicles like the XPeng X2 and the EHang 216 were filmed lifting off over bustling cities, turning heads and rewriting the future of transportation. It's not a demo. It's not a concept sketch. These aircrafts are flying, autonomously, powered by electric propulsion, guided by AI, and legally approved by Chinese authorities to take to the skies. While many in the US and UK are still stuck in traffic, China is building air highways. And in this video, we're going deep. We'll explore exactly how these flying cars work, what tech is driving them, who's building them, and why China is suddenly so far ahead in this global race. You'll meet the key players, understand the science behind eVTOL flight, and see what this means for smart cities, air safety, and even your daily commute 10 years from now. And stick around, because near the end, we're revealing which countries are quietly trying to catch up, and one of them might surprise you. The future is in the sky, and it's arriving faster than anyone expected. Just weeks ago, something historic happened in China, and almost no one in the West is talking about it. A flying car, the EHang 216, officially received type certification from the Civil Aviation Administration of China, CAAC. This certification isn't just a formality. It's the same kind of legal clearance an airplane needs to carry passengers. In other words, China has become the first country in the world to approve a fully autonomous passenger-grade flying vehicle for commercial use. Not a prototype, not a beta test, an operational vehicle ready for service. This moment marks a seismic shift, not just in how we travel, but in how nations are racing toward the future. The EHang 216 is a two-seater autonomous aerial vehicle, AV, that flies entirely on electric power, doesn't require a pilot, and takes off vertically like a drone. It has already completed thousands of test flights across multiple countries, including demo flights in the Netherlands, Austria, and even South Korea, but China is now the first to say, "We're ready to let people actually fly in this thing." According to EHang's official statement, the certification process took 1,000 days of review, 500 specific test flights, and intense inspections of structural safety, software redundancy, emergency systems, and environmental conditions. The CAAC concluded that the EHang 216 meets all the necessary requirements for airworthiness under real-world urban conditions. But the EHang wasn't the only major leap. Around the same time, XPeng Aero HT, another major Chinese electric vehicle startup, publicly tested its flying car model, the XPeng X2, in Dubai. This stunning pod-like eVTOL vehicle soared over the skyline in front of a global audience, including regulators, investors, and media from across the world. The XPeng X2 is more than a visual stunt. It's part of a bold strategy by XPeng to merge traditional electric car development with aerial mobility, effectively creating a dual-mode vehicle that could someday drive on roads and lift off into the air. What makes this different from competitors in the US and Europe is that these tests aren't happening behind closed doors or inside private hangars. They're public, government-approved, and backed by national policy. China's flying car moment wasn't just about showing off. It was a declaration: we are leading the future of urban air mobility. While companies like Joby Aviation and Archer in the US are still navigating tight FAA regulations, China is leapfrogging by streamlining its aviation approval process for electric and autonomous aircraft. The Chinese government is betting big on smart mobility as a key sector for economic growth and global influence. Urban air mobility, UEM, is even being written into China's official 5-year tech strategy, with designated air corridors already being planned in megacities like Guangzhou and Shenzhen. This isn't just about transportation. It's about technological dominance. The West has traditionally been at the forefront of aviation, automotive, and AI integration, but China is now combining all three in a way that's faster, more agile, and state-supported. Flying cars have gone from concept to certification, from showroom to skyline, in a matter of years. And while this might feel like a novelty to many in the US and UK, it's becoming reality in China, with footage, passenger data, and legal documentation to prove it. The sky is no longer the limit, it's the launch pad. And if you think this is just a Chinese phenomenon, wait until we explore how the rest of the world is scrambling to respond. Because behind the glossy videos and soaring test flights, a global race has quietly begun. So who's behind this flying car revolution in China? These futuristic vehicles aren't just science experiments from obscure labs. They're backed by well-funded, ambitious companies with long-term visions. And right now, 3 Chinese firms are leading the charge: XPeng, XPeng Aero HT, and Autoflight. Each is building their own version of the flying car future, and they're moving at a pace that's making even the most advanced Western startups look like they're stuck in taxiing mode. Let's start with XPeng, arguably the face of China's urban air mobility movement. Founded in 2014 and listed on the Nasdaq, XPeng has become a global name thanks to its autonomous aerial vehicle, the XPeng 216. What sets XPeng apart isn't just its technology, it's their total commitment to pilotless passenger flight. While most Western companies focus on piloted models to ease regulatory concerns, XPeng went all in on autonomy from day one. The 216 is compact, fully electric, and equipped with 16 propellers for vertical takeoff and landing. And most importantly, it doesn't need a pilot. It's controlled by an AI-driven command center that communicates with the vehicle and city infrastructure in real time. XPeng's vision is clear: fleets of self-flying taxis operating like Uber in the sky, without human error or gridlock. With its type certification approved by Chinese aviation authorities, XPeng is now pushing toward actual commercial deployment, something no Western firm can claim yet. Then there's XPeng Aero HT, a subsidiary of XPeng Motors, the electric car manufacturer often called China's answer to Tesla. Aero HT is working on multiple models, but their crown jewel is the XPeng X2, a futuristic 2-seater eVTOL that made headlines with its test flight in Dubai. Unlike XPeng, XPeng is blending traditional EV design with aviation, aiming to create a hybrid vehicle that can drive on roads and fly when needed. In 2023, they unveiled a new version of their flying car concept that includes foldable rotor arms, allowing the vehicle to transform from a car into an aircraft within minutes. It's a wild idea, but XPeng isn't treating it like a gimmick. They've raised over $500 million in funding and are already building a new R&D center in Guangzhou focused entirely on aerial mobility. Their roadmap includes a mass-market flying car by 2025, a bold claim, but one they seem serious about delivering on. Next is Autoflight, a lesser-known but fast-growing player in the eVTOL space. Backed by investors in China and Germany, Autoflight is developing the Prosperity Eye, a lift-in cruise aircraft that uses a fixed wing for horizontal flight and rotors for vertical lift. What's unique here is the aircraft's longer range, around 155 miles on a single charge, and its potential use in inner-city travel, not just short urban hops. In early 2024, Autoflight completed a record-setting flight of over 250 kilometers with its full-scale prototype, demonstrating both performance and reliability. While the company isn't as flashy as XPeng or XPeng, its focus on longer-distance electric aviation could make it a strong contender in the emerging eVTOL logistics and regional air taxi market. Now compare that with the US market, and the picture gets interesting. Companies like Joby Aviation and Archer Aviation have the technology, the funding, and the media hype. Joby, for instance, has partnered with Toyota and even received investment from the US Department of Defense. Their aircraft can carry 4 passengers plus a pilot, and they're working closely with the FAA to get certified. Archer has similar ambitions, recently going public and announcing a partnership with United Airlines for future air taxi routes. But here's the catch: none of these companies have received commercial certification yet. They're still navigating years-long approval processes with strict regulations and safety requirements. That's not to say they're behind in tech, but in terms of deployment, China is outpacing them by streamlining red tape and fully embracing this new sector at the national level. The West still holds the lead in aviation engineering and aerospace infrastructure, but China's air mobility startups are benefiting from a uniquely supportive ecosystem: government funding, fast-track regulations, and national prestige. While American firms are fighting to convince federal regulators, Chinese companies are already running test routes. This doesn't mean the US is out of the game, but the rules of the game are changing. And if Joby and Archer want to compete globally, they'll have to play catch-up not just in technology, but in the speed of execution. The skies are open, but only for those ready to fly now, not just dream about it. So now that we know who's behind this revolution, let's dig into the question that's probably circling in your mind. How exactly do these flying cars work? Because let's be honest, when most people hear the words flying car, their imagination jumps straight to something out of Back to the Future or the Jetsons. But the reality is both more grounded and way more futuristic. These vehicles aren't like traditional helicopters or planes. They're built on eVTOL technology, short for electric vertical takeoff and landing. That means they can take off and land vertically like a drone, without the need for long runways or complex airport infrastructure. Just imagine your local supermarket parking lot or a rooftop being turned into a mini skyport. The core principle is deceptively simple. Multiple electric rotors provide lift and directional control, powered by high-capacity batteries. These rotors spin independently, managed by real-time AI algorithms that adjust thrust levels, orientation, and stability hundreds of times per second. Let's break that down. Most of these aircraft, like the EHang 216 or the XPeng X2, use between 8 to 16 electric propellers arranged in symmetrical configurations. When it's time to take off, all the rotors fire up simultaneously, lifting the vehicle straight up into the air like a drone. Once airborne, some designs transition to forward flight using pusher propellers or fixed wings, a bit like how helicopters switch to cruising mode, but far more efficient due to distributed electric propulsion. This multi-rotor design makes them safer, too. If one rotor fails, the others can compensate almost instantly, maintaining stability without needing a backup pilot to intervene. But what really makes these flying cars feel like the future is autonomy. Many models, especially those by EHang, are fully autonomous, meaning no pilot, no joystick, no steering wheel. Instead, onboard computers and AI flight systems handle the entire journey. Passengers simply input their destination via an app or touchscreen, and the vehicle handles the route planning, altitude control, weather adjustments, and even traffic avoidance. Yes, there's air traffic routing just like on the ground. The aircraft communicates with cloud-based command centers that monitor multiple vehicles at once, ensuring coordinated flight patterns, no-fly zones, and emergency landings if needed. These aircraft are also powered entirely by electric batteries, making them quieter and cleaner than helicopters or traditional combustion engine aircraft. A typical eVTOL flight produces just a fraction of the noise, about 60 to 70 decibels, compared to 100 plus decibels for helicopters. That matters when you're flying over urban environments, where noise pollution is a real concern. In fact, several cities in China have already started mapping out low-noise flight corridors and vertiport locations specifically tailored for this kind of technology. And safety? It's baked into every layer. These flying cars are equipped with multiple redundant systems, from dual battery packs to emergency parachutes and real-time diagnostics. For instance, the XPeng X2 has a full parachute deployment system that activates if onboard systems detect a catastrophic failure. Most vehicles also come equipped with LiDAR sensors, cameras, GPS, and barometric altimeters, allowing them to see their surroundings just like a self-driving car, but in 3 dimensions. Combine that with machine learning algorithms trained on millions of simulated flights, and you get a level of situational awareness that even a human pilot might struggle to match. And we're not just talking prototypes here. Many of these systems are already undergoing certification. In October 2023, the EHang 216 received China's first ever type certificate for an autonomous passenger eVTOL, meaning it met rigorous safety standards akin to what commercial aircraft go through. That's not a science project. That's a flyable vehicle cleared for real-world use. So no, flying cars aren't some fantasy concept anymore. They're sophisticated, AI-powered machines built on cutting-edge drone engineering, electrification, and autonomous flight systems. They combine the efficiency of electric cars, the intelligence of AI autopilots, and the convenience of ride-hailing apps, all in the sky. It's not just how they fly that's revolutionary. It's how easy they make it to fly. The moment you step in, everything from takeoff to landing is handled for you. No pilot's license required. Just sit back, buckle in, and enjoy your commute from above. Now that we've explored how these flying cars actually work, the next question is, where are they flying? Because make no mistake, this isn't just a laboratory demo anymore. These futuristic vehicles are being tested, flown, and integrated into real urban environments right now. And while most people in the US or UK might still think of flying cars as a far-off dream, China and a few other regions have quietly built the launch pads for this aerial revolution. Let's start with Guangzhou, the home base of XPeng and one of China's most aggressive adopters of urban air mobility. The city has designated specific test corridors in collaboration with XPeng, where autonomous air taxis are being flown daily for cargo delivery, passenger testing, and emergency response trials. These routes aren't just for show. They've been integrated into Guangzhou's broader smart city infrastructure, which includes 5G networks, AI traffic monitoring, and cloud-based communication systems to support real-time air traffic control for eVTOLs. Local officials have even begun planning vertiports atop shopping malls and transit stations, making it clear this tech is part of their urban blueprint. Then there's Shenzhen, often called China's Silicon Valley. XPeng Aero HT conducted high-profile test flights here, showcasing their flying cars' dual-mode capability, driving on streets and then transforming to take off vertically. What makes Shenzhen especially important is the government backing. The city's tech-friendly policies and strategic investment in advanced manufacturing have given companies like XPeng a perfect environment to experiment and iterate quickly. It's one thing to fly a prototype in isolation. It's another to do it in a bustling megacity with real air traffic, infrastructure, and risk management protocols in place. But the most cinematic moment so far came outside of China, in Dubai. The XPeng X2 stunned the world during its 2022 test flight over the city's iconic skyline. Conducted in partnership with the Dubai International Chamber of Commerce, this wasn't just a marketing stunt. Dubai has committed to launching commercial flying taxi services as early as 2026, and the XPeng X2 is part of that future. Dubai's Roads and Transport Authority, RTA, is working closely with companies like XPeng and Joby Aviation to set up urban air mobility corridors mapped specifically for eVTOL flights between key urban points like airports, business districts, and tourist hubs. Across all these locations, one thing is clear: government support is the secret fuel behind this acceleration. From relaxed regulations for pilot testing to dedicated airspace corridors and citywide UAM strategies, these cities aren't waiting for the technology to mature. They're building the ecosystem around it right now. And that's what makes the gap between China and countries like the US or UK feel so significant. While Western regulators debate, China flies. Quite literally. So, how exactly is China pulling this off while countries like the US and UK seem stuck in slow motion? The answer isn't just technological, it's legal. More specifically, it's about how China's regulatory system embraces innovation through a radically different approach compared to Western governments. While American and British aviation authorities remain cautious and risk-averse, China is boldly rewriting the rulebook to let the future take flight. Let's start with the Civil Aviation Administration of China, CAAC, the country's top aviation regulator. In 2023, the CAAC made global headlines by issuing the first-ever type certification for a passenger-carrying eVTOL to XPeng's EH216s. That's a historic milestone. It means that XPeng didn't just build a working prototype, they got legal approval to fly autonomous air taxis commercially in China. In regulatory terms, this is the equivalent of a moon landing, and they did it years ahead of most competitors. So how did this happen? China's approach is what experts often call a tech sandbox governance model. Rather than forcing disruptive tech to squeeze into outdated laws, China creates experimental zones where innovators and regulators can collaborate in real time. These zones allow companies like XPeng Aero HT, Autoflight, and XPeng to test vehicles in real-world conditions, without waiting years for legislative changes. The CAAC is directly involved in these pilots, meaning that safety data and airworthiness protocols are developed iteratively, not reactively. It's fast, flexible, and deeply integrated with national industrial strategy. Contrast that with the United States, where the Federal Aviation Administration, FAA, has made progress, but remains constrained by legacy airspace rules and a deeply risk-averse culture. While companies like Joby Aviation and Archer are pushing forward, they're stuck in a multi-year certification maze. The FAA is cautious for good reason. After all, public air safety is paramount, but that caution comes at the cost of speed. FAA regulations for eVTOLs are still evolving, and there's no clear timeline for full-scale commercial deployment. The UK's Civil Aviation Authority, CAA, finds itself in a similar bind. While the CAA has shown interest in urban air mobility and issued roadmaps for airspace integration, it still operates under a very traditional aviation model. Piloted flights may gain approval eventually, but autonomous, fully AI-piloted aircraft like a Hang's EH216S, that could take a decade or more to pass through the system. Meanwhile, the CAA continues to emphasize simulation testing and small-scale trials over bold real-world experimentation. This difference in legal philosophy is pivotal. Where the West often treats innovation as something to contain until proven safe, China treats it as something to accelerate and then regulate from within. It's a bet that the future is coming whether we like it or not, and that countries who hesitate will be left navigating traffic while others soar overhead. So when we ask why China is ahead, the answer isn't just better batteries or smarter AI. It's the regulatory runway. China built theirs wide open and cleared it for takeoff. While China races ahead with flying cars already taking off in city skies, the rest of the world is in a high-stakes game of catch-up. The United States, the United Kingdom, and parts of Europe are home to some of the most promising eVTOL startups and aviation engineers on the planet. But despite deep pockets and impressive prototypes, they're still stuck in the hangar, grounded more by policy than possibility. Let's start with the USA, where companies like Joby Aviation and Archer Aviation are considered global frontrunners in the flying car revolution. Joby, for instance, has received a special airworthiness certificate from the FAA, completed thousands of flight hours, and even partnered with the U.S. Department of Defense and Uber for future commercial deployment. Their sleek, quiet, 5-seat eVTOL aircraft is designed to reduce traffic congestion in urban areas and cut travel times dramatically. Archer Aviation isn't far behind, with its Midnight aircraft targeting a commercial air taxi service as early as 2025. But while the engineering is world-class, both companies face regulatory roadblocks that delay scale. The FAA's rigorous certification process, although necessary for safety, is notoriously slow and bureaucratic. There's no fast lane, and for startups trying to scale quickly, every month of delay is a competitive disadvantage. Meanwhile, across the Atlantic in Europe, German startup Lilium has made headlines for its jet-powered eVTOL that looks more like a mini spaceship than a drone. With its unique duct fan design and ambitious range goals, Lilium is attracting serious investor interest. But the European Union Aviation Safety Agency, ESA, remains ultra-cautious, and Lilium's certification process could stretch well into the late 2020s. The company has secured launch partners and test zones in France and Germany, but it's still deep in the trial phase. Europe's fragmented aviation policy, split between EU-wide regulations and country-specific airspace laws, only adds to the complexity. In the UK, Vertical Aerospace is trying to carve out its own flight path. Backed by major players like Rolls-Royce and Honeywell, Vertical's VA-X4 aircraft boasts a claimed range of over 100 miles and is targeting commercial flights by the middle of the decade. The UK government has shown growing interest in urban air mobility, especially with London's congestion crisis begging for futuristic solutions. However, the Civil Aviation Authority, CAA, is still developing its framework for autonomous flight and eVTOL operations. Vertical has conducted successful hover tests, but full certification for manned or autonomous passenger flights remains years away. So, why are these companies in their home nations lagging behind China? It comes down to testing restrictions, airspace regulation, and public risk perception. In the West, regulators are terrified of a single crash derailing public trust in an entire industry. That's led to a climate of overcaution, where companies are often forced into prolonged simulation testing, years-long certification windows, and limited public demonstrations. The irony is that many of these Western firms, technologically speaking, are ready to fly. What's holding them back is paperwork. That's why the urgency is rising. Governments and investors alike are waking up to the geopolitical and economic implications of falling behind. If China becomes the global epicenter for urban air mobility, it won't just dominate the skies. It will control the standards, patents, and ecosystems that define 21st century air travel. That could leave US and European companies dependent on Chinese air infrastructure the same way they've become reliant on Chinese battery supply chains and solar tech. To counter this, we're starting to see action. In the US, the FAA is accelerating its roadmap for integrating eVTOL aircraft into national airspace, with promises of updated guidance and more flexible certification pathways by 2025. Congress is also beginning to look at flying cars not just as a tech novelty, but as a national security and competitiveness issue. In Europe, similar conversations are emerging, with several new test corridors opening in France, Spain, and Scandinavia. The global race is no longer about who can fly. It's about who can fly first, legally, safely, and at scale. And while the USA, UK, and Europe might still be in the game, the clock is ticking. Because the sky is no longer the limit, it's the new battleground. Flying cars might sound like something straight out of science fiction, but in China, they're beginning to take shape as real, everyday solutions to real, everyday problems. And as the dust settles from their first test flights, the conversation is shifting from can it fly to how will this actually change lives? One of the most immediate and practical applications already being explored is an emergency response. During congested city hours or in rural regions where ground access is limited, eVTOL aircraft like the XPeng 216 are proving they can serve as air ambulances, transporting medical supplies or even patients faster than any ground vehicle could dream of. XPeng has already demonstrated this in joint emergency drills with local authorities in places like Huzhou and Guangzhou. The autonomous nature of the aircraft, paired with quick deployment features, means that response times could be reduced dramatically, potentially saving lives where every second counts. Another rapidly growing use case is tourism. Cities like Shenzhen, Guangzhou, and Sanya have started to experiment with flying car sightseeing packages. Tourists can now book a short eVTOL ride over coastal skylines or cityscapes, getting a bird's-eye view of the urban sprawl in an aircraft that feels more like stepping into a sci-fi movie than a traditional helicopter. XPeng, in particular, has made these flights publicly available in test areas and has even hosted government officials and media representatives to experience the tech firsthand. The goal isn't just a thrill ride, it's normalization. By making flying cars an accessible public experience, China is softening the psychological leap for its citizens, building both excitement and trust in the technology. Intercity travel is another game-changing angle. Though still in its early stages, companies like XPeng Aero HT are envisioning a future where a commute from Shenzhen to Guangzhou, a trip that takes nearly 2 hours by car and traffic, could be completed in under 30 minutes by air. With urban air mobility corridors in the planning stages and several municipal governments backing the infrastructure, this is no longer just theoretical. China's sprawling urban clusters, so close in distance but so congested by road, make this an incredibly logical next step. In fact, pilot projects for air taxi lanes between select cities are already being discussed by the Civil Aviation Administration of China, CAAC, according to official CAAC planning documents. But what about the people? What do Chinese citizens actually think about flying cars buzzing over their homes? That's where Weibo, China's equivalent of Twitter, becomes a window into public sentiment. The reactions there are a mix of awe, humor, and practical concern. One user wrote, "I used to dream of flying to work. Now I just hope my boss doesn't buy one and expect me to beat traffic every day." Others are more reflective, calling it the arrival of the Jetsons era. But not everyone is sold. Some posts raise concerns about noise pollution, privacy, and even the fear of flying drones crashing into buildings. One comment with over 10,000 likes reads, "This is amazing," until one of them runs out of battery and drops on your car. That kind of skepticism isn't unique to China. It mirrors global anxieties about new aviation technologies. However, what's interesting is that the government and tech firms are actively engaging with this feedback, using it to design quieter engines, safer flight paths, and stricter operational zones. Several local media outlets have aired interviews with people who rode in early flight demos, many of whom described the experience as shockingly smooth, quieter than expected, and something I'd actually use if it was affordable. These impressions are critical because mass adoption depends not just on government approval, but on public comfort and trust. The companies know this. That's why every flight test isn't just a technical showcase. It's a public performance designed to win hearts and minds. In this regard, China is not only innovating the aircraft itself, but also the way people emotionally relate to this shift in mobility. They're laying the cultural groundwork for something that will soon become ordinary, not exceptional. And while the USA and UK still frame flying cars as part of the distant future, China's approach, test it, show it, let people ride it, brings that future crashing into the present with astonishing speed. As exciting as flying cars are, there's a side of the story that rarely makes the headlines: the challenges and risks that come with this futuristic technology. While the idea of soaring above traffic jams sounds thrilling, the reality brings up some serious concerns that demand our attention. One of the most immediate problems is noise pollution. Unlike traditional cars, eVTOLs rely on multiple rotors that generate a distinct, high-pitched whirring sound. Early tests in cities like Guangzhou and Shenzhen have already sparked complaints from residents living near takeoff and landing zones. The continuous drone-like noise, especially in densely populated areas, could lead to significant disturbances. Companies like XPeng and XPeng are racing to develop quieter propeller designs, but balancing performance with sound reduction is a tricky engineering challenge. This isn't just a minor inconvenience. Noise pollution affects mental health and overall quality of life, especially in urban environments already saturated with sound. Safety concerns are another major hurdle. While these aircraft come equipped with advanced autopilot systems and AI-powered collision avoidance, the reality of thousands of flying vehicles sharing crowded urban airspace raises the stakes. What happens if there's a system failure or a sudden loss of communication? The potential for mid-air collisions or crashes in residential areas cannot be ignored. Regulatory bodies like China's CAAC and the FAA in the US are rigorously testing these systems, but the public's tolerance for risk is low, especially when human lives are involved. Privacy issues are creeping into the conversation too. Flying cars packed with sensors, cameras, and AI systems constantly collect data about their surroundings. This opens the door to concerns about surveillance and data misuse. Imagine fleets of autonomous flying taxis recording everything below, from private backyards to sensitive government buildings. How will this data be managed, protected, or potentially exploited? The debate about aerial privacy is just beginning, and it's one that needs transparent policies and international cooperation. Another dimension rarely discussed is the environmental cost hidden behind the shiny exterior of flying cars. These vehicles rely heavily on lithium-ion batteries, and the production of these batteries involves mining rare minerals like lithium, cobalt, and nickel. Extracting these materials has been linked to environmental degradation, toxic waste, and human rights concerns in mining regions worldwide. While flying cars promise zero emissions in operation, the full life cycle environmental impact, including battery production and disposal, is complex and significant. Companies are investing in research for more sustainable battery technologies, but right now, the green credentials of flying cars aren't as clear-cut as advertised. Finally, there's the dark side of autonomy: hacking risks. With AI-driven flight controls and network communication, flying cars could become targets for cyber attacks. What if hackers gain control of an aircraft mid-flight? The consequences could be catastrophic. This fear isn't hypothetical. Cybersecurity experts have already demonstrated vulnerabilities in drone systems and connected vehicles. Governments and manufacturers must invest heavily in cybersecurity protocols to safeguard passengers and bystanders alike. In summary, while the flying car revolution is undoubtedly thrilling and full of promise, these hidden challenges remind us that technological leaps come with complex trade-offs. Noise, safety, privacy, environmental impact, and cybersecurity are issues that require ongoing scrutiny, not just from engineers and regulators, but from all of us. Keeping these concerns front and center will help ensure that when flying cars become a common sight in the skies, they'll do so safely, sustainably, and responsibly. Imagine a world where your kids never need to learn how to drive a traditional car, where the streets below are free from traffic jams, and the sky above becomes the new highway. This is not some distant sci-fi fantasy. It's the near future that China's flying car revolution is racing to create. As eVTOL technology advances and urban air mobility corridors expand, smart cities will transform completely. Flying cars could redefine daily commutes, emergency services, and even urban planning, blending AI, 5G connectivity, and green energy into seamless, efficient ecosystems. China's aggressive push toward integrating flying cars into its infrastructure is a glimpse into what smart cities might look like worldwide. Picture skyscrapers equipped with skyports, AI-driven traffic management systems orchestrating hundreds of flying vehicles simultaneously, and real-time data optimizing routes for speed, safety, and energy use. The promise is not only faster travel but also reduced pollution and a new wave of economic growth centered on tech innovation and new industries. Governments worldwide are watching closely, realizing that the future of transportation is airborne, and those who lag risk being left behind. However, this breathtaking vision comes with its own set of tough questions. Is this evolution a dream of a cleaner, smarter world, or a disaster waiting to happen? The challenges we discussed earlier, safety risks, environmental costs, privacy concerns, loom large. How we navigate these issues will determine if flying cars become a symbol of progress or a cautionary tale. What if the technology amplifies inequality, favoring the wealthy first and leaving others grounded? What if cyber vulnerabilities or regulatory failures cause setbacks? The road to an airborne future is thrilling but paved with uncertainty. Yet, one thing is clear. Flying cars are no longer a speculative idea. They are entering our skies now, and the choices made today by innovators, regulators, and society will shape the next century of mobility. For audiences in the USA, UK, and beyond, this isn't just a tech story. It's a glimpse into a transformative shift that could redefine how we live, work, and connect. So as you watch the skies, remember, this is your future unfolding, and it's more incredible, complicated, and urgent than you might have imagined. So, now that you've seen how China is soaring ahead with flying cars, what about the rest of the world? Which country do you think will take the lead in this high-stakes race for the skies? Will the USA's innovation and tech giants catch up? Can Europe or the UK carve out a winning spot? Drop your thoughts and predictions in the comments below. We want to hear from you. Your perspective matters as this incredible technology reshapes the future of transportation. If you found this deep dive into flying cars fascinating, make sure you subscribe to our channel. Every week, we break down the cutting-edge developments in AI, robotics, smart cities, and futuristic tech that are shaping how we live and work. Don't miss out on staying ahead of the curve and understanding how these innovations impact your world. Hit that notification bell so you're the first to get our latest videos. Thanks for watching, and buckle up, because the future is taking off, and you won't want to miss a moment of it.